Welcome back, everybody. So in this module, we're going to talk about how we actually analyze the fit of a logistic regression model. We're going to talk about how to actually diagnose some of the underlying assumptions that we still have just because we're running linear regression in the first place. And we're going to talk about this in the context of the example that we discussed at the end of the last module. So again, we're going to talk about how to diagnose some of the assumptions, like linearity. We're going to specifically talk about how to determine model fit, and I kind of briefly touched on that at the very end of one of the modules in which I was discussing hypothesis testing. So we can do a hypothesis test for an individual coefficient, or we could do an overall F-test, right, to see if any of the relationships are distinguishable from zero, or we could just see if a small subset are. And we were using the likelihood ratio test in order to determine that. And that's primarily what we're going to be talking about in this module. So again, just to kind of review what we're going to be using, instead of an AIC or a BIC, we are going to be using the deviance or the residual deviance to assess our model fit. And this is going to take on a very similar flavor as the residual sum of squares did in our OLS situation, in the sense that like a smaller deviance indicates a better fit, right? So just in the same sense that we want to reduce the amount of error, right? The residual that each observation has, and overall we want to reduce the sum of all of those residual or those squared residuals. The same thing is going to hold true for deviance. We are again talking about like a deviance from expectation. So it's the same kind of interpretation. What we're going to do is we're going to compare our deviance to null deviance. And then again, this is like very similar to the residual sum of squares, where we're going to essentially compare like the overall fit, and we're going to compare the fit of our null model, essentially no covariates, with our residual deviance, so the amount of deviance that we see in our full model, so all of our covariates. And again, the likelihood ratio test, or the chi-square test here, is going to be a comparison of the deviance that we see in a model in which we have no covariates, just the normal deviations that occur from our baseline expectations, essentially, in what we observe, and those in the residual model. So the null hypothesis here, right, is that all of the slopes, all of the relationships are equal to zero. None of the covariates actually help predict our outcome of interest. In this case, we're going to be talking about judges' propensity to decide female-related cases in a feminist direction. And our alternate then is going to be that at least one of these covariates has some relationship. And we're going to perform our likelihood ratio test using a chi-squared distribution. Now, remember that a chi-squared distribution has k degrees of freedom, where k is going to be equal to the number of coefficients that are essentially in your null hypothesis, right? So in our case, in the model in which we're modeling judges' behavior, our two covariates were whether they were appointed by a Democrat or a Republican president, and whether or not they had any girls as daughters or none. And so in that case, k is going to be equal to 2. And it's really simple, right? Basically, we're just testing to see whether or not the deviance between these two models is differentiable from each other. Now, taking our example from last time, we're going to essentially do this, right, where our full model is going to, again, be those two variables that I talked about, having at least one girl or more, and being Republican. And seeing here the null deviance, so the deviance in which we have no predictors, so here it would just be tilde 1. The null deviance is 2651. And here under the full model, right? So again, our degrees of freedom is going to be 3 less, right? Because we have this variable, the constituent term, right? So when you have just one for all girls, Republican equals 0, right? So you don't have an interaction term. So don't forget about the interaction term. That's where the 3, k equals 3 is coming from here.